Behold, Cameron, our second speaker. Cameron is a maker of things.
Yeah, I do
programmer,
stuff. Yeah.
Musician, founder of hackerspaces.
Serial founder. Yeah, that's about right. And then I have a day job.
Yeah.
Yeah. So this is a little story, not really super technical unless for some reason you want it to be, because this is more hardware than software. But this is a little story about practical hardware forking. So me and my roommate started a little thing called Suspect Devices. That's like the DBA for this other company that he used to work for. And we got a client that wanted to do logging of sensor data. So they had like this big refrigerator for allergens, and it had to stay at like pretty much 3 degrees Celsius. Like it could teeter a little bit, but mostly had to be within that range. So it kind of worked. The code made me want to cry because it was object oriented, and Arduinos cannot do object oriented. So it's just not how it works. So the other thing that they needed was a logger, and the logger, we looked at several. Like the one from SparkFun was kind of crap. We tried the hydrogen logger, and that was okay. I mean, it kind of seemed to work, but
Is this more complicated than just a micro SD card slot on the Arduino, or is it?
So it had to call home. It kind of had to be fail-proof because they had to be like they needed to be notified of any stuff, and like it does have like the refrigerator itself beeped when it needed maintenance, but they needed to keep track of all this stuff just because like there's a lot of accountability for like keeping around allergens. Yes?
So if there's a power outage, the power supply for this, is it the same as the one for the refrigerator?
Oh, I have no idea. Because I didn't work on the actual log. I didn't work on, or rather, I did work on part of the logger. I didn't this is more of a retrospective from the entire project. So we tried the hydrogen. That didn't really work out too well. And actually, this module is out of date. From what Gainspan has actually released. So, I don't know, updating that, just no. So we looked at some others, but like, the other thing about the hydrogen is that you have to use it in conjunction with an Arduino, which for production costs can get really expensive. We looked at the Teensy, but it's closed source. So we ended up with the Maple from Leaf Labs. I have one right here. And that was pretty interesting because it's ARM-based, and while the logger doesn't necessarily need to do like a lot other than logging, it was nice to look at as like a starting platform for other things. Like if we did this logger, then we ostensibly we could use it for a myriad of things. And also they were pretty cheap because they have another related board called the Maple Mini, which is super tiny. I have one right here. It's on my breadboard. Those are pretty cool.
Do you know which processor those use?
Yes. So the Maple is all based on the STM32. STM.
L or F or?
It's the super tiny one. Yeah, it's like the, oh God, I used to know all this stuff off it. Oh yeah, the 32F103.
What F?
Yes.
What's the F1?
Yeah, so these are like the super cheap ones, and which is nice because if we're doing a production run, all the stuff adds up. So we were like, okay, we're gonna get like one more besides like this. This is actually our only one. So if I lose it, we're screwed. But we tried to get more, and Leaf Labs was out of stock. They all of their vendors were looking for some more. Everyone on the forum was looking for more of them, and so we took it upon ourselves to start a little project called the Maplebacon. So the idea was that we could actually just manufacture this at home instead of actually having to do something else, because we needed to have just a few revisions so we can at least test the idea of having an ARM-based logger instead of an AVR-based logger or a PIC-based logger, because my roommate does PIC sometimes. So So the constraints for the Maplebacon, I even found one. Ha ha ha. They're like all over the house. The idea is that I can build this on a hot plate, and that it uses fewer components than the original Maple Mini, and the components are larger, so it's actually easier for me to put them on the board, and that the parts are actually arranged in such a way that it's like, when I'm like, put things, it's not too hard. And I think I've gone through at least like 6 revisions of this. So we got through a few of them on the hot plate, our $20 hot plate. We had about a 50% failure rate because $20 hot plates are not exactly very accurate in their temperature handling. So
It's an IR thermometer.
yes, yeah. The thing is that even the IR thermometer got to be a chore because we used the code from somebody wrote from Dorkbot to do the IR thermometer stuff.
I do it by hand.
Yeah, well, we used processing, and it was okay, except that there was a thing where it didn't shut off when it gets too hot, and we noticed that the IR, it melted a lot. So that code's been fixed, and it's on the internet somewhere. Then we were like, well, that's a lot of work, so we just sent them to Screaming Circuits, and then I started work on the, oh yeah, here's the schematic. All this stuff is all on GitHub. And I started work on the logger board, which uses the layered chips for Wi-Fi. And it also has a little connection for, there's a module from WizNet that does Ethernet. So we were just, you could kind of choose on assembly, like, okay, do I actually need the Ethernet one? Or you can have like 2 around. And so that turned out okay. I don't have one in the final assembly, but I mean, it kind of looks like this. And it had some lights that are on the end. And this whole thing is like, this little module like plugs back into the refrigerator. So that was, these were actually made by the people that made the refrigerator. So that turned out okay. I don't think we ever finished the project because they ran out of money. The refrigerator people ran out of money, but it turned out to be used in an art project. Meanwhile, Leaf Labs was working on another board. I mean, the Maple Mini was not in stock like through this whole time. So they were working on other boards which were more expensive and like using the way bigger STM32s, like just lots of crazy stuff. But nothing actually got that cheap. Then my roommate was like on eBay, like, oh, what's on eBay? And then he found this board. It is actually my Maplebacon with some modifications. They actually changed the buttons to be surface mount. They made some other changes in the power regulation, and that was like, that was interesting. And at first I was like, oh man, I can't believe somebody did that. But then I was like, wait, I can just buy them on eBay because somebody else has made them already. So it kind of was, it turned out okay. And actually, I emailed the guy. I was like, well, do you know that this is actually my thing that I worked on? And he was like, oh, okay. I didn't know that. That's cool. I just got it off GitHub. So I asked for a tarball of the changes, and he did give me a tarball of the changes. So
what hardware license did you use for this?
oh, all of this is BSD, I think.
So there is the Tapper open hardware license, which you might be interested in.
I know a lot about the open hardware licenses. I'm on the mailing list for the open hardware people. But I don't really care that much. I mean, because I personally don't have a vested stake in this. However,
what a suitable hardware license would be to ensure that you would get the changes back.
right. Well, except for the Chinese open source culture is very different, and so yeah, they're not going to send pull requests. However, I was really happy that the guy just emailed me all the changes, and that was I was like, wow, I was really impressed. So I had kind of largely given up on this project, but then there's this guy on the Leaf Lab forums, because, in this whole time, the Leaf Labs people are like, oh my God, we're super busy. We don't have time to actually do any releases anymore. And then a bunch of the forum members were like, I guess we should do something about this. So they stepped in, and a bunch of people actually came up with their own board, which is the Orone. And here is the Orone Mini. I've made a couple of these because I was one of the early testers, but I don't know where they are. I gave some feedback, and it uses some parts that I thought were really cool, mostly because they actually got the part number for the through-hole micro or mini USB, which I couldn't find for some reason. I'm not super good at looking for parts, but they found it, so it was cool. And it's actually still going on. Last month they just had another release of this board. This is also on GitHub. And that was very exciting. But unfortunately, this the whole Leaf Labs is now kind of moved forward, just doing contract work. But I felt it was a really interesting lesson in how forking actually plays out practically. So I have some takeaways, which is one, always talk to your maintainers of hardware, because they're around. They actually kind of want feedback. If they have it open source, they want to talk to you. Maybe not all the time, but they're around. And there's also the nice thing is we were pretty public about what we were doing, so we did get some feedback from other Leaf Labs members, and that was really exciting too. And they and everyone else was doing their own spin-off, so it was really cool to see all of this kind of coalesce into the community supported version. Document your fork. I learned a lot about documentation, and I think what I would have done in the future would be to set up, in Git, I would have set up a pre-commit hook to generate a PDF, so that way people, if they do have changes, they can actually easily say, oh, okay, I don't have Eagle on this machine right now, but here's here's some stuff. I had some guy at Dorkbot come up to me and actually write in some changes on a printed PDF, so that was cool. Also, I wish I would have documented my failures, because as G. Bulmer learned, having me do testing because I'm more of a novice, and he was teaching a class with his hardware, it was really good that he knew what I had encountered when I was building it, so that he could actually continue to make a better version for students. And I wish I'd done this more for the Maplebacon. Also, I learned it was a good idea to actually engage people, engage the cloners. I know that not all of them are going to be really responsive, but it was really cool to actually get the source codes, because I didn't think I would actually get Gerber files from this guy, and that was cool. Yeah, that's pretty much it. Any questions or comments? Yes.
Did you get as far as getting some code onto the Maplebacon?
I personally didn't. Well, actually, no, I take it back. I did get some code on it. I made a little LED multiplexing board that was using another project that has since died called libmaple. And I actually was really more excited about libmaple because it was basically it had both the Arduino style editor, which actually is a processing style editor. But it also had a library that you could compile against, and so you can actually use a code editor, yeah, like normal coding. So that was really cool. Also, the libmaple was a few versions ahead. The compiled one that was, the one that was embedded in the IDE was behind. But I only used the IDE because I was just trying to play around. And that actually turned out pretty good. One of the mistakes that I made was actually leaving the USB pins exposed, because we had a few people kill their Maplebacons. That was a little bit awkward. Well, if you ask the USB pins to do things besides USB, things get a little wonky.
Oh, I see. You expose them in the software interface.
Well, no, both. But you can actually plug things in I think it's like what, yeah, pins 23 and 24 have like input, so you could potentially fry this sucker. What was the, yeah, there's some other code stuff. Oh, right, so one of the things I wanted to do that I never got around to was like, building a plugin for Sublime, but it never, I got busy. I had a day job.
Cool.
Yeah,
So are you still?
oh wait, this guy first.
Maybe tangentially related. How does GitHub work as far as tracking changes for these hardware projects?
Well,
Work with the formats for Eagle or whatever tool that you're using.
so I usually use Eagle, just because the other library, basically Adafruit and SparkFun both support Eagle, and I think recently I forgot somebody was going to move to KiCad, but I don't know if that actually happened. And KiCad is not stable on the Mac, and I usually use a Mac. So I actually hate Git for doing any kind of Eagle files, because it doesn't like binaries very well. And I was using Eagle 5 at the time. It's not as squishy with Eagle 6, but after that I actually started using Mercurial a lot more, and I ended up using Mercurial at work, so that turned out pretty well. The only thing is that GitHub has all the fancy stuff, and people like it, and you can do the pull requests or whatever, but you can't even really do diffing. And that was the other thing that, yeah, so you can't do diffing. What I did was I had a PDF on one part of my screen, and I had Eagle open on the other, and I was like, I wonder what kind of changes are happening. What did Don do?
Well, I've used visual diffs between Gerber files pretty effectively.
Okay.
And you put the two layers on top of one another in different colors, and you can actually see diffs pretty easily.
Yeah.
Visually. The other thing I use is GEDA instead of Eagle or KiCad, and then
Yeah.
use a text format file, and you can actually look at the diffs.
Yeah, RoboBird was telling me about that one. RoboGirl.
You get used to reading its text file format, which is probably not a good thing.
One of the things I used to do was spit out a text format and just run diffing Perl script across it and say, what's changed? And it was,
Yeah.
Latest Eagle does XML.
Exactly.
And so you can diff the XML with XML tools or with normal tools.
Right.
But it's about as much fun as what these do.
Right.
Developers to put in good commit messages.
Yeah,
And good luck with that.
I don't even put in good commit messages.
Use version control at all.
exactly.
Well, we're ahead of the curve apparently.
But just a visual diff with the raw Gerber files is surprisingly effective.
And what are you using for the visual diff? Just oh, okay,
Both layers.
Load both layers. And
Okay.
different colors. Yeah, it's pretty easy.
okay. Yeah, thanks. Write that
And
down.
there was some differencing, Gerber differencing tool that I used. I don't remember what it was. It actually would highlight the differences in different colors. It's even cooler. I don't remember what tool that was. But it
Yeah.
did just take Gerber files.
Okay, because I tried to write one in JavaScript for the Eagle files on the plane, but I don't know why I didn't finish. A lot of unfinished projects.
Had a day job?
Yeah, I think it's, day jobs. My old day job used to take up a lot of time. This day job, not so much. So
Would you use libmaple again? Is it still going on?
so libmaple is in a funny spot because, as far as I can tell, they've stopped. They may still be pushing changes, but it's not. They may not be keeping up with documentation. Like I actually had to give them a pull request for documentation because a lot of their links were broken. So there's kind of a danger in that. However, the nice thing about the Maple, the Maple forums and the Maple community is that they're they're pretty gung ho about it. So I'm sure that if anybody wanted to go back into that, they could. And it seemed, it had some rough edges because I think that their API wasn't finished in some parts, but I thought it was pretty cool. I don't know, advanced users may have difficulty, but I don't know. Any other questions, comments, something, dancing? Yeah, that's it.